What's up, YouTubers? I took a couple day break. I've been knocking out videos, tons of videos on my vacation I took, which since it's winter, I didn't really go anywhere, and I just decided why not spend 12 days straight making videos, and that's kind of what I did. So I took a couple days off after that, and now I'm back. And this is sort of a viewer submission request. I was planning on doing this anyways, but shout out to the guy that recommended it, because I definitely think it's a great idea, and that is, why don't we test 60-10 rods on clean versus mill scaled up steel? Now, I'm also going to do a video down the road in a week or two where we use 60-10 on really scabby material. Like, I'm going to use a ton of salt and water and leave some of this steel outside. It's the middle of winter here in Wisconsin, and just let it rust as bad as I can for like 2 weeks, and then we're gonna try and weld that together and see what happens. But yeah, so anyways, today's video is clean versus mill scale, 60-10, what's the differences in how the weld looks and the penetrations. So let's get into it. So our test pieces are 1/4 inch thick steel. As you can see, absolutely no prep on these guys, other than I ground the dross from torch cutting them. And then this is as clean as you're ever gonna see this kind of steel. And then we're gonna be doing fillet welds. So I cleaned the bottom as well as the sides. And this all got cut from the same bar. If you look at this, hopefully it comes out, like literally this is like 2, maybe 3, definitely 2 pieces of paper thick. Like, it catches your nail really easily. Like, this stuff is not good. Definitely can't TIG weld through that. I did a little short video on that a long time ago, and no good there. But this is the same steel from the same bar that I did the 70-18 test, no, I actually believe it was 60-13 test. Whatever it was I used, there was a difference in the bead appearance. The penetration may be slightly different, welding on scabbier material versus clean, but the way the weld looked was definitely poorer on this. But 60-10 is a totally different game per se. The rod itself has really good penetration, and it's well known to chew through pretty much anything, paint and mill scale. So we're going to use what's known as 5P plus. The reason I'm choosing this over the red rods, the 5Ps, is because this has a little bit more fluid of a puddle, and this is kind of like in the middle of all the 60-10s I've run. Now, I have a video upcoming that teaches you how to weld with 60-10. In that video, I discussed the differences, but this rod is kind of like a good baseline where if you run any 60-10, it's going to run somewhat similar to this. So that's why I picked it. So anyways, let's get started up. I'm going to tack these together, and then we'll get to welding them. So I got these tacked up. I was kind of an idiot and tacked it up a little bit, favoring one side. So I did the same on this guy. It's not going to make too much of a difference. That will get heat soaked a little bit quicker. It may slightly improve penetration on that side, but realistically, I don't think it's going to make a difference. Just to stick with the clean theme, I'm going to just prep this one a little bit better, and this one we're going to leave as is. I'll do 2 passes, so I'm going to do a pass on each, let it cool, then do another pass on the other side, let it cool, cut them in half, and then we're going to see what we got. As far as settings go, I'm running 90 amps. I'm running the Miller machine at 65% dig, which is what they recommend for 60-10. So on your machine, you're looking at somewhere between 55 and probably 70% arc force. Miller calls it dig, your machine may call it arc force, or you may not have any adjustability on it, and that's fine as well. So just as a heads up, this plate is about 6 inches long. So you can see that it actually takes a long time to weld this with 6010. Your travel speed with 7018 is actually a little bit faster simply because it deposits more metal. But you can see it's going to take me a while to make this whole weld. And you can use this kind of to your advantage when you're welding fillet welds with 6010 to gauge if you're going too fast or not. That took pretty much exactly 1 minute to weld, so you're looking at about 10 seconds an inch for travel speed. So before I even clean these up, I noticed a difference in welding them. Now I had a little bit of a goof up here where my hands kind of got bound up. But welding this, it was almost like the molten puddle wanted to go where it wanted to go. I couldn't really direct it. Like I tried to manipulate the rod angle to try and hit a little bit more of the lower plate because it kind of just seemed to want to chew away at the top plate only. And it almost looked like the arc, the puddle didn't want to wet down in here. So I was kind of manipulating a little bit. And it almost looked like the whole leading edge and top like edge of the weld pool was just undercutting into the plate. Now what I was probably seeing was it digging in to the mill scale, and I was probably seeing that mill scale edge, which to me looked like undercut, but visually they didn't look anything alike. Gives a good idea. I'm gonna film the arc on both of these and then show you what I'm seeing so that you can see it as well. But I'll let these cool off, wire wheel them, and then we'll start up again with some arc footage. So this is clean material. I want you to pay attention to how that liquid puddle seems to be pretty consistent, like the overall eye shape. Pretty liquidy, pretty well defined. The edges of it don't seem to be jagged. You don't really see it melting into the metal, kind of like undercutting. It just, I don't know, it looks clean. Just pay attention to that. So this is on dirty metal. I want you to pay attention as the arc and the molten puddle moves forward. You can see it looks like it's undercutting the plate, and that's just the mill scale layer there. And pay attention to how it sounds and how the puddle flows. It seems to be crispier and throwing far more spatter than the clean plate. So before we do a cut and etch on this, I thought we should just go over the results. Now this is the first pass here, clean. Don't mind that arc strike I had accidentally. So this is the very first pass that I made. It's a little bit rough, had my hand positioned incorrectly and kind of forced too much rod in there. Not looking too bad. You can see there's a little bit of slag left on this top toe, but for the most part, from my eyes, and you might not see it on the camera, looks pretty clean with not really any evidence to speak of undercut. Here's the second pass, went a little bit better. Again, a little bit of slag on the top toe. Bottom cleaned off pretty good. Yeah, I mean, that's looking pretty good for 6010. Now let's look at the dirty material. This is pass 1. I noticed that the toe line tends to be a little bit more inconsistent in height. Now a lot of that could just be my travel speed. However, it just seems like it didn't wet out consistently. Like when you look at this, if you look at that top toe, I mean, I guess, I don't know, it just seems a little bit rougher. More hard spatter on this, especially down here. I mean, you look at how many buckshot BBs are on that versus there's just a couple small pieces, and then on the other side, just small pieces. Nothing big like that. The other thing is that it's hard to tell, but it looks to me like there is like some undercut in little small patches around here. Some of it could just be mill scale, but I mean, definitely rougher looking. Let's look at that second pass here. Again, the height of it just seems to be inconsistent. And if you saw in the video, I mean, I was pretty much traveling the same. I mean, maybe a little bit faster on the second pass versus the first. This side doesn't have too much spatter on it, so this ran a little bit better. Yeah, I know, it's really hard to tell what's undercut and what's not, if there is any. So, all right, well, let's cut these in half and then look at what the results are. Dun, 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 dun. We have our results. I have the clean one cut and etched and a dirty one. So let's go through them. We'll start with the clean one first. So here we have the clean one. First pass right, second pass left. First pass on the right, you can see a little bit of undercut at the top toe of the weld. I believe that's due to the angle I had the rod at. If you look at it, it's more or less hit the bottom plate more than the top. Had I had a flatter rod angle, that would have solved that. And you can see in the second pass, I definitely had a flatter rod angle, and that all looks good. So both of these, other than that little bit of undercut, very clean welds. They're pretty flat if you look from toe to toe. They're not really humped up or anything, so no surprises there. Penetration, being that 6010 on 1/4 inch plate at 90 amps with 1/8 inch rod, is looking exactly like what you want. Stick welding in general has pretty good penetration, and 6010 has definitely got good penetration. So here we have the first pass in the dirty on the right, second pass on the left. The bead profile on both of these, a little bit rougher, I guess. If you look at the bottom toe of the D1, you can see there's undercut there, and there's actually a fair amount of undercut down the weld that you'll see later. On the second pass, there's undercut at the top toe as well. Both of these had similar rod angles. The penetration is going to be similar to the clean metal. 6010 doesn't seem to care much about what you're actually welding through. The penetration is pretty consistent. However, there are obviously more defects, and the profile of the welds seem a little bit less consistent. And this is just one area cut and etched, but the whole weld, and again, you'll see it later, is very similar to this, where it's just more inconsistent on a dirty material. So this I thought was pretty interesting. It's a second pass for both welds, and if you look at the clean weld on the left, marked C, versus the dirty material, you can see the dirty material, the weld is more humped up and rope-like. The clean material, it's flatter and wetted out better. So there is a difference. And again, all of these rods, 4 separate brand new rods, all the same material, were all run at 90 amps, no difference there. So quite a bit different on the profile. This is a little bit harder to see, but from my perspective, looking at them in person, the clean material has a flatter weld profile. It wetted out better. There's obviously a lot less spatter and a lot less, I don't know, chunkiness to it. If I had to pick one, the clean material in both cases, both welds I did, clearly wins. I prefer the way the penetration looks as well as just the overall bead profile. So let's look at some profile shots kind of like head on. This one pretty consistent on wetting out. This is on clean material, not a whole lot of spatter. The profile is really acceptable. I would say a little bit flat. I like the look of it, no real issues. This one here tied in the bottom plate a little bit more than the top, but the profile's overall acceptable. No real issues there. I don't see any evidence of undercut, no spatter to speak of, so no issues. Here's the dirty material weld. You can see there's a bit of inconsistency in the bead itself. Now, I'll just blame myself on that. We do see some spatter. I see evidence of undercut on the toes where you see little dark dots. That could be undercut, and we'll look at that from another angle, but the weld profile doesn't look as good as the clean material. Now this has excessive spatter. I mean, I guess not excessive, but more spatter. You can see that there's probable undercut on the toes, and we'll see that in another photo in more clarity. The weld itself just looks, I guess, grainy. Doesn't look like it flowed out really nice compared to the clean material. This really shows some defects. If you look on the right toe line for about 2 inches, all of the darker area there is actual undercut. Now, I didn't get any undercut on any of the clean material like that, so the mill scale seemed to help contribute towards that. I kept a tight arc gap. I wasn't really whipping very far. I wasn't letting the rod dig in and increasing the amperage with the arc force or anything. I pretty much just ran it like you normally would with minimal manipulation, and yet here we have a significant amount of undercut. I gotta say the results were a little bit different than what I expected. I mean, I kind of expected the 6010 to have a little bit more defects, like maybe a little bit more undercut, but I didn't expect the profile of them to be as different as they are. And when you're looking at it here in kind of like the large zoomed out scale, it's not really noticeable. I mean, when you really zoom in with a camera and look at it, it's more or less night or day difference, but out here it's more subtle. But I gotta say, if I had to pick between the two, obviously I'm gonna take the clean material. I mean, far fewer welding defects, less spatter, the profile looks better. The one thing is the penetration for clean versus dirty, really not that different. I mean, I would say based on what I'm seeing is that they're gonna be equal. So realistically, 6010 will chew through mill scale, no problem, but it comes at the expense of more spatter, more undercut, and overall roped up bead in comparison to clean material. And let's face it, I mean, I'm a realist. You're not gonna be able to prep all material perfectly. I mean, if you're underneath a trailer welding on something and it's an emergency, like you might not be able to get a grinder or a die grinder in there. Like, I totally get that. And in that case, 6010 is definitely your go-to. I mean, the penetration through this thick a mill scale, I mean, pretty deep. It made it better than an 1/8 inch into the material. So 6010 lives up to the hype and into its reputation in that respect. It's just, obviously, again, just like in the previous video, is prep your material, you know, the best you can. Sometimes you can't prep it that well, so, you know, do your best, grind the rest, as the saying goes. With that said, hopefully you enjoyed this video. Give me a thumbs up if you thought it was pretty interesting, and I always like hearing your comments, so if you have anything to share, feel free to share it. Until next time, guys, thanks for sticking around.